What's special about this telescope?
The special
Brian Butcher,
one of a kind.
President of the Des Moines Astronomical Society. Andy Carr,
How you doing?
Brian's a teacher and artist. Jim Holloway from Newton, Observatory Committee member. Ed Ramsel, Observatory Director. Andy Carr.
Association. You're a horse right now. That's just my
Now, who made this scope?
Wave Optics. It's a special edition Patriot model. Yeah, it's got the stars and the eagle. They only made one with the Iowa engraving on it. And when you buy one of these special telescopes, Wave Optics will donate, match a donation to the Red Cross, not Iowa Red Cross.
Oh, okay. Now, is this the only Iowa scope?
That's the only Iowa.
Now, is that because nobody else has bought one, or is it the only Iowa? It's going to be the only Iowa
It's going
scope.
to be the only Iowa.
Cool.
They only made one with Iowa.
There are no prominences on the sun, but usually you can see flares and sunspots and that sort of thing with this particular filter.
It's clouds right now, so it's...
What are you looking down there?
We're looking at the tower, reading the serial number. See if it's the same tower that was there last week.
Or if they went up and repainted it.
Change the numbers on it.
Yeah, change the numbers.
Original class system. And we'll show you the other classroom in a minute. But this is some of the equipment that we have here, and Jim can tell you a little bit more about it. But this is an electronic eyepiece. We can put this eyepiece in any of the telescopes, and we can show the sky on this 9-foot screen.
That's like my favorite
LCD
eyepiece.
projector. So we have public nights every Saturday night that you know about, and then twice a month we have a lecture, and most of the folks use that.
So
You've got the schedule.
You just attach that to any one of the telescopes?
Pardon?
You attach that to any one of your
Yes.
telescopes,
Yes.
and then you're able to project the view from the scope here for an audience.
Yeah, as long as we can get a wire out to it, and it just takes a coax cable to it. We normally hook it up to one of the dome telescopes, and the domes are wired to go directly here. And this thing will lock in on a star, and it will telescope you're going too fast, you're going too slow by just fractions of a millisecond, just milliseconds. And it actually adjusts the telescope over a long period of time to keep the guide star in the middle of the field, so your images that they may take, 10 minutes or whatever, very difficult, but that they don't get oblong and out of focus. So that's a pretty sophisticated piece of
What was it
equipment.
called again?
It's called an auto guider. It also is a CCD camera, and it can be used for imaging and that kind of thing, but it's pretty sophisticated. So this,
As I trip up the stairs.
Brian was telling you about the ash dome. So the shutter,
You go ahead and move on in.
the door here is motorized, and it goes down to here. We crank this one up manually. That one raises automatically. And then the thing turns. So it'll turn 360 degrees. This mount is older. It's made by Parallax. They have moved, I think, to South Carolina now or something, but it's a very fine mount. It's probably at its capacity with this telescope. This is the one that had the smaller 12.5-inch telescope, and we adapted it. The mount, the mechanical mount, in very precision gears and servo motors, this sort of thing, you can hear if you want to take a look. I'll show you the thing is following Venus right now. This is lined up with the North Celestial Pole. And so as the telescope, as the Earth moves in this direction, the telescope moves in this direction at precisely the same speed. And so its focal length is a long focal length and has to do with resolution. Light comes in, hits a mirror back here, which is 16-inch mirror, reflects it back to a mirror in the front, which is smaller, and that in turn reflects it back through here and across this diagonal and out here, and that's what you see. So the telescope itself is 4,000 millimeter focal length, but we have a focal reducer that flattens the field and puts it down to about 25-60. But if you want to do photographs or some high power observing, you take the reducer off. But anyway, lots of things. This is a good diagonal, and this is just a pretty standard. I think I have a 32 millimeter eyepiece. Power of a telescope is related to the focal length of the eyepiece and the focal length of the telescope. The aperture doesn't have anything to do with power. It has to do with resolution and light collection. Take a look. Planet Venus, you can't see it yet. You'll see it shortly, but it's up there in the cloud. You can see, if you look, you can see a little flat spot on it. It's about 3/4 full at this point. A little shorthand, but it says object, and we want to go to something in the solar system, so I push 4, and we want to go to Saturn, so I'll push 7. Now we know Saturn's over there, and it does know that too.
You got it?
Oh yeah.
All right. He's so proud of himself when he gets that.
So I'm going to move it a little bit. How about that?
Okay. Yeah.
So I'm moving the telescope manually. That's how we adjust it using these 4 directional north, south, east, west. So you can see the rings there. It takes 2 people to handle that mirror. We had it out to clean it. So you can see, this is the glass mirror right here, 16-inch. So that mirror is a parabolic mirror, and it's designed so that it hits this diagonal. Remember I showed you the obstruction-free one?
Mm-hmm.
Well, this one's got it in the middle, so there's a diagonal, shoots the light right down here, out there, and that's a little over 2,000.
Does it make a difference how, it doesn't matter whether it's up
Well,
or not?
Actually, the old timers, and probably even me, I prefer less glass. I like the reflector telescope. My personal telescope is a reflector, but they're big, not very portable. But this is let's see, we put it in last spring. It's commercially available, called an Argo Novice, made in Australia. But the way this works is that you have it set on a star, and you tell it to go to another star, and it says arrow this way 16, and you move it that way until it's 0, and then there's an arrow goes this way and it says 12, and you move it till it's 0, and when it's 0, 0, it's on the object. So I like to find stuff without assistance, so I like a non-drive telescope, and this is good for that.
Why?
It's a challenge. I just saw it a minute ago. Yeah, that's pretty.
Hey, up there.
Sunset out of the dome. Actually,
Hello, up there.
hello.
Hello.
We love technology. We don't look very high tech, but when you start looking at the toys.
Basically, right now I'm only using 2 cameras. I've got a Canon 20D digital.
Okay.
All right, and I got a T-adapter that fits in it, and that'll fit right in to its focus. Little standard webcam.
Sure.
You pull your lens out, and then you can get an adapter,
Okay, huh.
and you just screw your adapter in, and then that'll also fit in an 1.25" focuser. And then I've got 3 different programs that I can use to acquire images. And what it does is I can take a movie, say a
3-minute movie. Basically, it's a 3-minute movie, but it's all individual frames. And then I've got programs that I can go in and I can go through, and it'll pick the best. It'll take all the images and it'll pick the best ones and put them in order from best to worst. And then I can go in and say I take 3,000 images. Well, I can go through and I can look, well, I like 5% of them, so I can pick 5%, and then I can go through and I can process them and end up with a halfway decent picture.
When did you get into doing this?
Well, that's weird. I was when I was a kid, which was a lifetime ago. I was with a bunch of other kids. We got into astronomy with binoculars. And then as I got older and got interested in girls and drinking and all that other good stuff, I kind of got out of it. And then, I don't know, about 5 or 6 years ago, I didn't even know they had an observatory up here, and one of my friends was coming up. He said, why don't you come? And I got up here and got looking around, and I remembered, you know, all the stuff that I always wondered about. You know, what's that bright star? You know, what's that look like? And it kind of amazed me looking through the telescopes. And then when I saw the pictures, you know, the Hubble stuff, and even though, you know, so I just decided I got a camera, and I started taking a cheap camera and started taking pictures, and was amazed what the difference was, even with a cheap camera, and the pictures that you could get versus looking through an eyepiece. So I'm just kind of slowly stepping up a little bit by little bit by little bit.